This is the Analog Discovery 2. Now, chances are you already own one of these because you're watching this video. However, if you don't, this is a multi-function data acquisition device for students. It's got analog input, analog output, digital I/O, as well as a variable power supply. And it's small enough to fit in my pocket. Now, the Analog Discovery 2 is not meant as a replacement for traditional labs, but rather it's meant as a complement to the lab. It's meant to be able to bridge that gap between theory and hands-on exercise when you can't fit that extra hands-on exercise into a lab. And I would like to show you how this is possible through a few different labs. We and I have created these complementary labs for electrical engineering. And it's a collection of 7 different labs for 5 different courses. That's right, this is not a drop-in replacement for a class, but rather it's a starting off point. It's meant to give you an idea for what you can do to better utilize your analog discovery. So those 5 different courses that we've tried to touch on with these 7 different labs are Intro to Circuits, Circuits 2, Intro to RF, Intro to Power Electronics, and Digital Communications. So if you teach any one of those classes, make sure to download the attached labs so that you can get an idea of how you can better utilize your analog discovery. I would like to show you an example of one of those labs. So let's investigate UART communication using an analog discovery 2.
Hi, my name is Ali, and I was really interested in UART communication, so I designed a lab using our Digilent UC32, where you can just use your Arduino device as a drop-in replacement, and then it sends in signals to our analog discovery 2. This allows us to visualize and really see how UART communication transmits and is received by other devices.
As you can see right here, I've made a VI to send a signal from the UART to the analog discovery 2. So over here we're sending an unsigned data type, which means it can go from 0 to 255. Let's jump it up to 21. I've picked UART channel 2, and then I've set the standard baud rate as 9600, and then the serial port is COM3, which is what it's configured to. So now let's run this, and now let's jump to this VI, which was set up with the analog discovery 2. And as you can see, it has a waveform and it has a digital waveform matrix. So there's a couple of different ways to visualize how the data is coming in. We once again set the analog discovery 2 as a device name. We're going to manually sample it with the 9600 once again as a baud rate. And now let's try running it. As you can see, I'm getting a clear signal. We can take a look at exactly how the data is coming in. So let's stop this really quick, zoom in, and then you can see it's going to go from 1 to 0. So this is your start and this is your stop bit, and then we're having the binary representation of 21, and the equivalent is happening in this digital waveform matrix. We can even change the number in real time. So let's change it to the highest it can go, which is 255. And then we'll note the difference that it mainly stays 1 because 255 is 1 in all binary.
For more labs like this, download our Complementary Labs for Electrical Engineering.